Saxon Advanced Mathematics. Hi Jayla, this is a video for you to explain these reciprocal function problems. There are two of them that you gave me. I'm going to explain this one right now, and I want you to try this second one, 2713, after you watch this. Ooh, it's functions. After you try this one, hopefully 24-9 will make more sense to you. Then I want you to try 2713 on your own. I think one of the biggest problems with these problems is that John gives you so many words and it looks confusing and hard. So erase all of that and let me just remind you of something really simple. Here is a function, y equals x, and it looks like this, right? And we mark on this two important places where y equals 1 and where y equals -1. That's what those two places are. Just pretend with me. I don't have the numbers on, but that looks right. Because those places are important because that is where the reciprocal function is going to be the same as the original function. Let me show you what I mean. Okay? If this is the original function, then this is the reciprocal function, right? We just flip it. No big deal. And I don't want to get into showing you all the charts of numbers because that gets really confusing. But when x is equal to 1, y is equal to 1. But over here, when x is equal to 1, y is also equal to 1. So this point will always be the same. It'll always show up in both solutions. Same for -1. Over here, when x is equal to -1, y will also be equal to -1. Same thing here though. When x is equal to -1, y is also equal to -1. So these 2 points will show up in both of them. But the reciprocal function takes a very different shape. It goes from there to hug the x-axis that way, and then it goes there to hug the x-axis that way. It'll always be like that. And then the same thing happens down here. Again, if you have any doubts or want to prove this for yourself, just make a chart and choose some values and figure it out. But I don't want to do that now because that'll just confuse you. This relationship always exists between reciprocal functions. One's a line, the other is a pair of curves, and they're always going to have 2 points that they share in common. And that's what John's trying to tell you in this problem, but he just gets so carried away with it. What he's doing, though, is he's taking this basic equation and he's making it a little bit messier so that this isn't such a neat, perfect line. So let's look in problem 24.9 what he's doing. Here's the graph, and the parent function, if you will, that he's using is, now he's switched from this notation. Remember, when we have this, we can also say f of x equals x, and we can say f of x equals 1 over x. You can change that, and either way is exactly the same. So don't let that confuse you. This one is f of x equals x minus 2. So John has graphed this for us, and as we can see, the slope is 1, the y-intercept is -2, so it's going to look like this, right? That's going to be the way that it pretty much looks. It's going to be at -1 right there, and if you put in the point, it will be +1, -1, right? We want the place where y equals 1 and where y equals -1. On this one, y will equal -1 when x equals 1, right? Because 1 minus 2, oh, that's -1. Y will equal -1 where x equals 2, and then y will equal positive 1, where x equals 3. So these are the 2 points where we're going to get the same value, whether it's the parent or the reciprocal function. Bear with me. This point is 1, -1. We've already got that one marked. And the other one is 3, 1. So 1, 2, 3, 1. So right about there. That's going to be the other pair of points. And so we can see that right here is going to be like this axis, right? It's going to be where the line crosses over from up to down. All right, so what we're trying to do is we're trying to take this line but sort of reorient ourselves to the x and y axes so that we can reorient the kooky little asymptote things too. So I'm going to draw, oh shoot, I put away my, all right, well, I'll just use this color. I wanted to use a different color, but I put my markers away. So what we want to do is figure out how would we draw these curves if we were drawing the reciprocal function. Well, let's look at what the reciprocal function would be. It would be f of x equals 1 over x minus 2, right? And let's see what happens when we choose x equals 1, because we said these 2 points, these two, should be the same. I'm going to circle them so you know. Those 2 points should be the same for the reciprocal function too. So let's test our theory. If x equals 1 in this, then what's y going to equal? 1 minus 2 will be minus 1. 1 over minus 1 is minus 1. I'm just plugging those in. And what about this one? We chose x equals 3. And 3 minus 2 is 1. 1 over 1 equals 1. So look, we're going to get these same points again in the reciprocal function. They work for both. So what that tells us is that, let me draw it in again. We want these same points to be on our reciprocal function. And I'm doing this super the long way, okay? 1, 2, 3. We want 1 and -1, that's there. And we want 3 and +1, that's there. That shows us that the dividing line between them is going to be right there, right? Just like the dividing line between them was right there. And that means we know we're just going to go from that point, like so, and like so. Okay? So what we do is we know that this is the basic relationship, and this one we just scooched over, right, a little bit. And so we scooch this one over the same way. Make sure we have those reference points, the points where the parent function and the reciprocal function cross over, and it's where y is equal to 1 and -1. That's what we're looking for. That's how we find that pair of points, is where y is equal to 1 and where y is equal to -1. That's what John's trying to say in all those long words. It's confusing. So how do you do these problems? You know that the shape is going to be like this, and it's going to be off a little bit. John gave you all this information in the answer. So really, all you have to do to solve this problem is draw the picture the way John does in the book, and then just from these points, add that, and that, and that, and that. And now you're done. That's all you would have to do. Ooh, I wish those were more perfect, but you see what I mean. You don't have to draw it separately. You don't have to do these calculations. You know, I take the line John had, I identify the place where y is -1 and y is +1. Those are going to show up in my reciprocal function. I look at where the middle is. John's drawn it in. All I have to do is make my curves work. So this is the answer, but you can draw it over the top of the other picture. Jayla, this is one where the words make it seem so much harder than it is. So Try not to get caught up in all of those words and just focus on the picture and those 2 points where y equals 1 and negative 1. Text me after you watch this and tell me if it makes sense. Go ahead and try this one before you message me and see if you can get that one. But again, just look for these points and look for the dotted line. John draws it in. That's all you need to know to see where to get those in. All right, good luck. Let me know how it goes. Reciprocal functions, we're not going to let them scare us. Okay, bye.